So now let's graph a function of an exponential. K of x equal to e to the power negative x squared. Let's see. If I switch x and negative x, I will have a symmetry. I will have the same answer. Therefore, there is a symmetry about y-axis. Other thing that I noticed, domain is all, I can plug in any real number in there. The other thing that I notice is as limit as x goes to either infinities is going to be 0, because it's basically you can do a u substitute, u be equal to x negative x squared, and then you see that the limit as x goes to either infinities becomes a limit of e to the x as x goes to negative infinity, or let's say we said u substitute, so limit of it basically becomes limit of e to the power u, as u goes, either of these become that goes to negative infinity, and therefore that is equal to 0, as we know. Also, I noticed that it's because an exponential, and there's no shifts or any transformations, the function is always bigger than 0. So we found that no vertical asymptote, horizontal asymptotes are y equal to 0, and we found that it's symmetric. Now, let's take the derivative of the function. Derivative of the function is the exponential itself times the derivative of the exponent, which is negative 2x. And then the second derivative is going to be a product rule. So the second derivative is the derivative of the first term, which is negative 2 times the exponential, and then plus negative 2x times the derivative of e to the power negative 2x, and you end up with this. Now, use these to find the points of interest. Points of interest for k prime is 0, for k double prime is negative plus and minus 1 over square root of 2. And then we put them all together. Remember, when I'm graphing k prime, when I'm finding the sign for k prime, I know that k prime is going to be, the sign of k prime is going to be the opposite sign of x, basically. And so over here, it's going to be positive over here, and then it becomes negative after that. The sign of k double prime are depending on the sign of this part, and so I have to figure out this is a quadratic polynomial, therefore it's going to be positive on the two ends, and the sign, because if I factor this, I will get square root of 2x minus 1 times square root of 2x plus 1, and each 0 is of order 1. The sign should change as I cross the zeros, which it does. And over here it changes, and over there it changes. So from what I see here, I can see that there is a point of inflection, 2 points of inflection, one over here and one over there, and I see that from the sign of k prime, I see there is a maximum at x equal to 0. So put all that information together, and you see over here I have to have basically this shape. Over here I have to have this shape, and then over here I have to have this shape, and over there I have to have this shape. And if I put them together, and remember that x equal to 0 is a horizontal asymptote, This is the shape that I get. Now, I notice that the local max here is a global max, and the points of inflection are marked also